All right, so let's deal with an example. And we'll switch over from a football to a soccer ball. I'm going to take a circle, and we'll say it has radius a. So this is 0, and this is a. And I'm putting it in this particular spot for a reason. You can do this in lots of different ways, but I'm picking this one to make a certain exercise that on your homework easier for you, because I'm doing half of it for you right now. All right? Yeah, appreciated. Yeah, I'm sure, especially today, it's appreciated. So again, the formula has to do with keeping track of these slices here. And we're sweeping things around. So the full region that we're talking about is the volume of the ball of radius a. That's what our goal is, to figure out what the volume of the ball of radius a is. All right. Again, as I say, the thing sweeps around, coming out of the blackboard, spinning around on this x-axis. All right, so the setup is the following. It's always the same. Here's our formula, and we need to figure out what's going on with that formula. And so we need to solve for y as a function of x. And in order to do that, what we're going to do is just write down the equation for the circle. This is the circle. It's centered at a, 0, so that's its formula. And now there's one nice thing, which is that we really didn't need to find the formula for y. We only needed to find the formula for y squared. So let's just solve for y squared, and we won't have to solve a quadratic or anything. Take a square root. That's nice. This is a squared minus x squared minus 2ax plus a squared. The a squareds cancel. These two terms cancel. And so the formula here is 2ax minus x squared. All right, now, that is what's known as the integrand. Well, except for this factor of pi here. And so the answer for the volume is going to be the integral of pi times this integrand, 2ax minus x squared dx. And that's just the same thing as this. But now there's also the issue of the limits, which is a completely separate problem which we also have to solve. The range of x is from this leftmost point to the rightmost point. So x starts at 0, and it goes all the way up to what's the top value here? 2a. And so now I have a completely specified integral. Again, and this was the theme last time, the whole goal is to get ourselves to a complete formula for something with an integrand and limits, and then we'll be able to calculate. Now we have clear sailing to the end of the problem. All right, so let's just finish it off. We have the volume is, if I take the antiderivative of that, that's pi times ax squared, whose derivative is 2ax, minus x cubed over 3. That's the thing whose derivative is minus x squared, evaluated at 0 and 2a. And that is equal to pi times, let's see, 2 squared is 4, so this is 4a cubed minus 8a cubed over 3, right? And so all told, that is, let's see, 12 thirds minus 8 thirds pi a cubed, which is a maybe familiar formula, 4 thirds pi a cubed. So it worked. We got it right. Let me just point out a couple of other things about this formula. The first one is that from this point of view, we've actually accomplished more than just finding the volume of the ball. We've also found the volume of a bunch of intermediate regions, which I can draw schematically this way. If I chop this thing, and this portion is x here, then the antiderivative here, this region here, which maybe I'll fill in with this region here, which I'm going to call v of x, is the volume of the portion of the sphere, volume of portion of width x of the ball. And, well, the formula for it is that it's, the volume is equal to pi ax squared minus x cubed over 3. That's it. So we've got something which is actually a lot more information. For instance, if you plug in x equals a, not surprisingly, and this is a good idea to do because it checks that we've actually got a correct formula here. So if you like, you can call this a double check. If you check v of a, this should be the volume of a half ball. That's halfway. If I go over here and I only go up to a, that's exactly half of the ball. That had better be half, so let's just see. V of a, in this case, is pi, and then I have a cubed minus a cubed over 3. And that turns out to be pi times a total of 2/3 a cubed, which is indeed half.